In today's video, I'm going to share with you the answers of Science Paper 1 of 2017. And this past paper question was a GCE past paper. Don't forget to like this video and subscribe to my channel. And specifically, I'm going to look at the solutions of question B2. So let's get started. Question A reads, what is the difference between density and relative density? 1 mark. Question B reads, figure B2.1 shows a cuboid container that has a 5 cm square base and contains water to a height of 6 centimeters. So as you can see from the diagram, the cuboid has the square base of 5 centimeters and the height is 6 centimeters. Roman numeral 1, what is the volume of the water? Roman numeral 2, a stone is immersed into the water in the cuboid, causing the water to rise to a height of 8 centimeters. Determine the volume of the stone. 2 marks. Question C reads, if the mass of the stone is 80 grams, calculate the density of the stone. 2 marks. And the total marks of this question was 5 marks. Question A reads, what is the difference between density and relative density? 1 mark. The difference between density and relative density is that density is defined as the mass per unit volume, while relative density is defined as the ratio of the mass of any volume of a substance to the mass of any equal volume of water. Question B reads, figure B2.1 shows a cuboid container that has a 5 cm square base and contains water to a height of 6 centimeters. So as you can see from the diagram, the square base is 5 centimeters and the height is 6 centimeters. Roman numeral 1, what is the volume of the water? So to find the volume of the water in the cuboid, the first thing that I'm going to do is to write the formula that is used to calculate the volume of the cuboid. So volume is equals to length times breadth times height. So volume is equals to, the length is 5 centimeters and the breadth is 5 centimeters multiplied by the height. The height is 6 centimeters. So 5 multiplied by 5 multiplied by 6. My answer will be 150 cubic centimeters. So the volume of the water in the cuboid is 150 cubic centimeters. Question B, Roman numeral 2 reads, a stone is immersed into the water in the cuboid, causing the water to rise to a height of 8 centimeters. Determine the volume of the stone. 2 marks. So this means Roman numeral 1 was 1 mark and Roman numeral 2 was 1 mark. So to find the volume of the stone, the first thing that I'm going to do is to find the final volume. After finding the final volume, I'll subtract the initial volume from the final volume, and that will be the volume of the stone. So to find the volume, I'll say volume is equals to length times breadth times height. Then my length is 5 centimeters multiplied by my breadth is 5 centimeters, and my height, after immersing the stone into the water, my height will be 8 centimeters. So 5 multiplied by 5 multiplied by 8, my final volume will be 200 cubic centimeters. And to find the volume of the stone, I'll say my final volume subtracted by the initial volume. So the final volume is the volume that I'm just from finding, which is 200 cubic centimeters. So I'll say 200 cubic centimeters minus the initial volume, which is 150 cubic centimeters. So the volume of the stone is 200 cubic centimeters minus 150 cubic centimeters. That's 50 cubic centimeters. Question C reads, if the mass of the stone is 80 grams, calculate the density of the stone. 2 marks. So to find the density of the stone, the first thing I'm going to write the formula of density. So density is equals to mass divided by volume. And the mass of the stone I'm given in the question, which is 80 grams, divided by the volume of the stone, it's 50 cubic centimeters. Then I'll say 80 grams divided by 50 cubic centimeters. My answer will be 1.6 gram per cubic centimeter.